All right, mathletes, here's 6.1. We're going to take notes here on inverse trig functions. First one we're going to look at is sine of x. So remember, sine of x is our function here in the blue. It's symmetric to the origin starting here. What we want to do is deal with this issue that this is not a one-to-one function, meaning it does not pass the horizontal line test. Because we want a function that passes a horizontal line test, so when we find the inverses, we don't get multiple answers. We can see here that if we were finding a value, let's just say this is 0.6, there's many places along the sine graph that you're going to have that solution. So we want to restrict our domain here. So what we end up doing is we're going to just do exactly that and restrict the domain. So we're going to restrict the domain for sine graph from negative pi over 2 to pi over 2. If we restrict the domain and say none of this exists from here over, we get this graph, which is negative pi over 2 to pi over 2, and we know we get values of 1 to 1. The nice thing about this, negative 1, the nice thing about this is that this is a one-to-one and onto one-to-one and a function passing the vertical line test and the horizontal line test. So as we look at these inverse functions, the big things to note here is that our domain becomes our range and our range becomes our domain. So what do I mean by that? So for our normal sine function, our y values went from negative pi over 2, that's our domain, to pi over 2. So when we're looking at our inverse function, this is now our domain. So you can see in the graph here that the blue is our inverse function. Our domain of this function was the range of this function. And what was the range of this function is now the domain of this function. The values have flip-flopped. Okay. When we're doing inverse functions, we realize that the inverse undoes the function and you're left with the original argument. And it goes both ways, that the function of the inverse of that value will give rise to your solution there. The domain of this graph is from negative 1 to 1, and that's the range, and the domain of this, which was the range of this graph now became the domain of that graph. Okay. Big thing that we really need to understand here is that when you're asked, find the sine of pi over 3, this asks you to find the value. In other words, what's your ratio of side lengths? So sine we know is opposite over hypotenuse. We associate that and call that the value. Sometimes I'll say, think of it as a ratio, because that's what it is. Remember, our ratios, our values, that's these coordinates in our unit circle. That's your x and y coordinates. Specifically for sine, that is our y coordinates. They are ratios. Okay? So when it asks you to find that value, that's what you're using. You're inputting your angle. Your angle is here or there. Okay? Inverses, they are now giving you the ratio, and they're saying, can you find the angle? So notice when you're doing these, it's having a good basis of understanding that the sine of theta your angle always goes there, is equal to your ratio, okay, and that your inverse sine function, your input is the ratio, and what you'll find is the angle that you're searching for. So making sure you understand the similarities and differences in those two equations. So if we want to find the exact value of sine of square root of 3 over 2, yes, sine of square root of 3 over 2, that's a y value, is going to happen in two places. But remember, it really happens multiple places because we can keep going around and around this circle. But we've restricted the domain just to include our quadrants 1 and 2, from negative pi over 2 to pi over 2. So the one answer that we're going to get is right here at pi over 3. So algebraically, we can type this into our calculator, inverse sine of square root of 3 over 2. It's in this interval, and we find that our y is pi over 3, which is our theta, which is in this interval. How I'm going to refer to this in this class, this is your principal angle. Okay? This is similar and analogous to when you did square root of 9, you got 3, and you called that your principal root. But we know that if you have x squared is equal to 9, that really there is two roots. X is equal to 3 or negative 3. But your calculator only gives your principal root, so you have one answer. The same thing in here. You're only going to get one answer as your principal angle. All right, so cosine. Cosine is very similar, but in the context that our domain is going to be different. If we only restricted our domain from negative pi to pi, we would only have positive values here, and we wouldn't be able to get our negative values. So what we end up doing is working on a different domain for cosine graphs. Cosine graphs, we're going to say, all right, let's cut it from 0 to pi. Then we can get the positive values and we get the negative values. So we can see this is going to be our function that we're going to work with. Take that function of cosine of x and we're going to flip it. Okay? So so here in red, we can see that this is our cosine of x. We went from 0 to pi. That is our interval. Okay? And our range went from 1 to negative 1. So just like we went from 1 to negative 1 here and 1 to negative 1 there. Our inverse function, the function here in the blue, notice what was once our domain and range were flip-flopped, 0, 1 to 1, 0. And what was pi to negative 1, we get negative 1 to pi for our inverses. When you look at a sample problem, if we're trying to find cosine is equal to negative square root of 2 over 2, think back to our unit circle. Cosine is dealing with our x value. Well, yes, there's two places where it's going to be negative square root of 2 over 2. So we need to find the angle because inverse is looking for a theta. So what theta is it going to give us? Remember, for cosine, we're only dealing on the interval from 0 to pi. So this is going to be our principal angle. Okay, so that principal angle right there is 3 pi over 4. Thing with tangent, again, we need to recognize that it's not 1 to 1. So we're going to restrict the domain. The domain is going to be the same for our sine graph from negative pi over 2 to pi over 2. And when we flip that, we're going to get our inverse reciprocal functions, very similar to sine. What was our domain became our range and inverse. Make sure you highlight any questions you might have and bring them up in class tomorrow.